Hi, this video is on ionic compounds. It's really a lot of review from everything we've learned this semester, but I'm kind of putting it all together for you. So let's get started. So, as the name implies, ionic compounds are made from ions. It's a combination of a positive ion and a negative ion, and those opposite charges attract, and it's this attraction that forms the bond that's called an ionic bond between our positive ion and our negative ion. So what forms that positive ion that we call a cation? Well, it's formed by an atom that has lost electrons. Well, what kind of atom loses electrons and why? Well, the answer is metals. Metals like to lose electrons. And so as you can see on this periodic table, the left-hand side of the periodic table are the metals, and it makes up about 75% of the periodic table. Well, let's just review some physical properties of metal. They have luster, or they're shiny, they're good conductors of heat and electricity, and they have high melting points. What about some chemical properties? Well, they easily lose electrons to form cations, and they corrode easily. But why would they want to lose electrons? Well, it's all based on their electronic structure. They like to lose electrons so they can form an electronic structure that is the same as a noble gas. Now, they're the same element. They didn't lose or gain protons, but they have lost electrons, and now their electronic structure is similar to those of a noble gas, and that makes them more stable. So let's think about the alkali metals. They're very reactive. They all have one valence electron. Let's go ahead and have a look at sodium's electron configuration. Neon 3s1. That 1 is its valence electron. Potassium, it's in the same family. Its electron configuration is argon 4s1. Again, family members have similar chemical properties because they have the same number of valence electrons. Well, sodium would love to lose that one electron, and then it would have an electron configuration that would be the same as neon. So then we would say that sodium with a +1 charge, so after it loses that one valence electron, has the same electron configuration as neon, and that makes it very stable. And potassium will do the very same thing. It will lose that one valence electron so that it becomes isoelectronic with argon, and now it's very stable. All right, so let's just review some charges on the metals. And again, this is the positive charge. Well, the alkali metals are +1. The alkaline earth metals are +2. Aluminum is +3, zinc is +2, and silver is +1. Transition metals can have different charges, and the only way that you know their charge from a name is that they will give you the charge in parentheses as a Roman numeral. So if they're naming something called iron 2, that means it's an iron ion with a +2 charge. But iron can also form a +3 ion, and so it would be called iron 3, or that would be the iron with the +3 charge. So an iron atom that has lost 3 electrons. Polyatomic ions. There's only one positive polyatomic ion, and that is ammonium. And what I want to make sure of is that you guys never change that subscript. Ammonium is NH4, and it has a +1 charge. Make sure you never change that subscript 4. It's NH4. Now, here's the thing. This is not a metal. Nitrogen and hydrogen are nonmetals, but it is a cation, so something that has ammonium in it is going to be an ionic compound. All right, well, ionic compounds are made from ions, a positive and a negative ion. We now know that the metals are losing the electrons to form the positive ion, but what's forming the negative ion? So, anions are the ions that have a negative charge, and they acquire that negative charge by gaining electrons. What kind of atom gains electrons, and why? Well, the answer is nonmetals. Now, we know that noble gases are stable, so they really, even though they're nonmetals, they're not going to be gaining any electrons. They're stable just like they are. But these nonmetals here would like to gain electrons to have an electronic configuration that would be the same as the noble gases. Now hydrogen, you know, it's kind of in a class of its own. It normally is +1, but it can be -1. We're not going to worry about it right now. All right, let's talk about the nonmetals. Let's review their physical properties. They're dull in appearance. They are poor conductors of heat and electricity. They have low melting points. They can be solids, liquids, or gases. But their chemical properties are that they gain electrons. They like to form anions. And so let's see why. Nonmetals will gain electrons so they can have an electron configuration similar to that of a noble gas. Well, let's take a family here, the halogens. They have 7 valence electrons. They're very electronegative. They really would love to attract 1 more electron so they would have a noble gas configuration. Here's chlorine. Its electron configuration is neon, 3s2, 3p5. This 3 is our outer shell, and so let's sum up all the electrons in the outer shell. A 2 plus a 5, it has 7 valence electrons. Well, if it were to just gain 1 more electron, and now we call it chloride, it's no longer chlorine, this is now the chloride ion, and it gained 1 more electron, and now it is isoelectronic with argon. So it has the same number of electrons and the same electron configuration as argon. Makes it very stable. Here we have bromine, the atom. The electron configuration is argon, 4s2, 3d10, 4p5. Let's have a look at valence electrons. The outer shell is the 4 shell, so let's sum up those electrons. 2 plus 5 gives us 7 valence electrons. That 3d10, those are not valence electrons. They're not in the outer shell. The highest number here is our valence shell. So bromine has 7 valence electrons. If it were to gain just 1 more, it would have the electron configuration of krypton, and that would make it very stable. So indeed, that is the ion that chloride and bromide form. Again, we're seeing here that family members have similar chemical properties because they have the same number of valence electrons. What about polyatomic anions? There are a lot of them. You may need to look them up, but remember, never change the subscript on a polyatomic ion. And then here we have our periodic table, our cations, our metals that form the positive charge, our nonmetals over here that form a negative charge, remembering that our noble gases don't gain electrons. And then here in tan, these are metalloids, and they can act like a metal or a nonmetal. All right, well, let's talk about ionic compounds. You're going to combine the number of cations with the anions so that their charges will cancel, and the ionic compound is neutral. So here is the aluminum ion. Hopefully you remember it forms +3. Sulfate, that 8 ending should clue you in that this is a polyatomic ion. It's SO4 with a -2 charge. Now, when we combine these to form aluminum sulfate, so we put the cation's name first and then the anion's name, we need to put these together so that they have no overall charge. Well, aluminum is +3, sulfate is -2, and in class we talked about the crossover method. We need 2 aluminums and we need 3 sulfates. 2 aluminums, and with a polyatomic ion, if you have more than one, you have to put it in parentheses with the number of those polyatomics outside the parentheses, so that subscript 3 outside. Again, never mess with that subscript on a polyatomic ion. We're just balancing their charge. We need 2 aluminums and 3 sulfates to get a balanced charge. All right, here is what you guys are going to do to practice this a little bit more. You're going to be given 4 cards. Each card is going to contain the name of an ion. It could be a cation or an anion. The name should help you figure that out. If you don't know the formula for the ion on your card, you can look it up using your computer. You take your first card and you find someone that you can combine with. So if you are a cation, you need to be looking for an anion. On a separate sheet of paper, you're going to write the name of the ionic compound that the 2 of you would form. Remember, write the cation's name first and then the anion name. And then, working together, you're going to write the formula for that ionic compound. You're going to use that very same card and go find another person that you can combine with. And you're going to write the name and formula of that ionic compound that the two of you formed together on your paper. You're going to repeat steps 2 through 5 for each of the remaining cards. So what are you going to turn in? Well, all in all, you're going to have 8 formulas with ionic compound names and formulas that you formed with your classmates. You're going to turn this in at the end of class, but make sure your name is on the paper. And then tomorrow, be prepared to take a quiz. Don't really worry about this. We're just going to make sure that you know this process, that you've got this down. You don't need to memorize any polyatomic ion for the quiz. You just need to understand the process. All right, well, have fun writing those formulas for ionic compounds. See you tomorrow.